Okay, day 14 video, which is for Wednesday, April 15th. I'm going to be going over the review for the quiz for section module 19, and it's permutations and combinations. So the first one, Roman numeral 1 here, 1 is permutation of 6 things taken 3 at a time. It's just a formula. I want you to show this by hand in order to get credit for it on the quiz. It's going to be 6 factorial over 6 minus 3 factorial. And that denominator is going to end up being 3 factorial. So the numerator, I'm going to roll down 6 times 5 times 4 times 3 factorial. And the 3 factorials will cancel out. Therefore, we got 6 times 5 times 4, or 120. Combination of 8 things taken 6 at a time. Again, the formula for combination, very similar. 8 factorial all over 8 minus 6 factorial times 6 factorial. So that's going to be a 2 factorial. I'm going to roll down the 8 times the 7 times the 6 factorial all over. 2 factorial is just 2 times 1 times my 6 factorial. So those 6 factorials will cancel out. I can take the 2 into the 8 4 times, and 4 times 7 is going to be 28. Now we're just going to take a permutation and multiply it by a combination. So permutation of 9 things taken 7 at a time is 9 factorial all over 9 minus 7 factorial. And we're going to multiply that times combination of 7 things taken 4 at a time, so 7 factorial all over 7 minus 4 factorial times 4 factorial. All right, so that's only going to be 2 factorial. So I got a 9 times an 8 times a 7 times a 6, so forth, so on, until I get to the 2 factorial to cancel out with the 2 factorial. So got a lot of numbers there. 2 factorials are going to cancel out. 7 I can take down to 4, so 7 times 6, 5, and then 4 factorial. And this will be 3 factorial, so 3 times 2 times 1 times my 4 factorial. The 4 factorials here are going to cancel out. That's going to be 6, so I can take that out. So we're going to multiply all these numbers together, and that comes out to be a whopping 6,350,400. And as I said, tomorrow on the quiz, I do want to do these by hand. Of course, using a calculator to do something like this. But write the formulas out, substitute in, and show the proper cancellation. That's the only way you're going to get full credit for those. Okay, Roman numeral 2. Some confusion on some of these. You guys have the problems in front of you. The first one's about the NCAA has applications. We got 6 universities. They want to host the tennis championships for 2 consecutive years, 2008, 2009. How many ways can they be selected if they cannot be held at the same university? So basically, we've got a combination. That's all we're looking at is a combination of 6 things taken 2 at a time, because once the one's picked, it's out of there. So the combination, the way that can happen, is going to be 6 factorial all over 6 minus 2 factorial times a 2 factorial. At this point on the quiz, no need to show me work. If you've got a calculator that'll do it for you, go ahead and just tell me it's going to be 15 ways. Another way you could have thought about this problem is we've got the year 2008 and the year 2009. There are 6 universities possible here and 5 universities possible there, but that gives me 30. We've got to divide out the 2 factorial, these 2 factorial, of which ways it can happen, because I don't care which way it happens. So I've got to divide out those permutations to get my combination. And that's where you would get the 15. Okay, number 2. Number 2 is a straight basic counting principle. You're buying a TV. You've got choices. You've got the type of screen. You have the size. You have the manufacturer. And that's all your choices. So if I have 3 different choices, I just multiply them together. There are LCD or plasma. We've got 6 different sizes and 3 different manufacturers. So that would give me 36 possible TVs. All right, number 3. We got a multiple choice test. We got 4 questions and A, B, C, D, and E for that. In how many ways could a student fill in the answers for each and every question? This is just a basic counting principle. They might be the hardest ones to identify. So we've got 4 questions. That's it right here. 4 questions. I got 5 choices here, 5 choices here, and 5. Doesn't matter what I pick for the first one. Second one's going to get the same number of choices. So you get 625 choices. Number 4, how many ways can 5 people line up to get on a bus? Well, the way they line up is an order is important. So I'm talking about a permutation. I've got 5 people and I'm going to pick all of them. This is the one that is that straight linear permutation where it's going to be 5 factorial divided by the 5 minus 5 factorial. So we get 5 factorial all over 0 factorial. 0 factorial by definition is equal to 1. So it's just going to be 5 factorial or 120. All right, number 5. We've got, in how many ways can 8 people form a circle for a folk dance? Well, it's a circle, so it's going to be a circular permutation. Circular permutations are the formula n minus 1 factorial. So we're just looking at 8 minus 1 factorial, and that is 5,040 different ways. 6, how many arrangements are there of the letters in the word great? None of those letters repeat. So basically, I'm just looking at how many different possible permutations can I make with those letters. So it's a permutation of 5 things, taken 5 at a time. We know that's just going to be n factorial. So that's going to be 5 factorial, or 5 times 4 times 3 times 2. And that is just like the previous one. Well, not previous one, before that one. 120. All right, number 7. How many arrangements of the letters in the word statistics? Well, it's a linear permutation of those letters, so that's going to be n factorial, but I have to divide out the repeats. So put down here like a p factorial, whatever they are. And I think we have 3 letters that repeat. So the total number of letters is going to be 10. So it's going to be a 10 factorial divided by, well, let's see, we've got 3 S's. So for the S's, since there's 3 of them, I have to divide out a 3 factorial. I've got 3 T's. So I'm going to take 3 factorial again because I have 3 T's. And it looks like 2 I's. And I have to divide out the repetition of those I's. So on your calculator, you take 10 factorial divided by 3 factorial, 3 factorial, 2 factorial. You're going to come up with 50,400. Like I said, the first 3 problems, I want you to show the work. Here, you need to write the formula and then get the answer on your calculator, and that will get you your full credit for that. That was 7. Did I mark these wrong? Yes, this was 6, and this was 7. Okay, number 8, where you got a production of Grease. There are 8 actors that are to be considered for the male roles. I want to know, there's 3 of them. So I want to know in how many ways can the director cast the male roles. Well, they're not lining up in any order. However, if you're chosen to play Danny, you certainly cannot be chosen to play Keith. So it is definitely a permutation. It's a permutation of 8 things taken 3 at a time. So it's going to be an 8 factorial all over an 8 minus 3 factorial, which would be a 5 factorial. And that would give me 336 different ways that can happen. Number 9, we got an art collector. He owns 8 original paintings, is preparing a will. And how many ways can she leave these 10 paintings to her 3 heirs? It doesn't matter which ones I get, which ones you get, or which ones the other person gets. So it's going to be a combination. And we've got 10 total paintings, and we're divvying up 3 ways. So a combination of 10 things taken 3 at a time is 10 factorial over 10 minus 3 factorial times 3 factorial. And that will give us 120 different combinations. And it looks like the last one, number 10, we got 4 pairs of pants, 7 shirts, and 3 sweaters. He's going on a trip. He's only going to pack 2 pairs of pants, 3 shirts, and 1 sweater. How many ways can you choose to bring these clothes? All right, so we've got pants, we've got shirts, and we've got sweaters. Now, he's got 4 pairs of pants, but he's only going to pack 2 pairs of pants. And I don't care which pair I pick first or which pair I pick second. So I'm going to do a combination of my 4 pairs of pants, taking 2 at a time. And then I'm going to multiply that, because it's a basic counting principle, but I have to do this combination to get how many ways I can get the first problem. It's going to be a combination of 7 shirts, and we're picking 3 of those. And I'm going to multiply that by a combination of, what do we have here? 3 sweaters, and we're going to take just 1 of those. All right, so a combination of 4 things taken 2 at a time is 6. Combination of 7 things taken 3 at a time is going to be 35. And the combination of 3 things 1 at a time is simply just 3. So that gives us a total of 630 different possibilities. Not an easy problem, but once you see one, it might jump out at you. The hardest thing, I think, is getting these basic counting principles away from the straight permutation or combination. If you have choices, and for each choice you have other choices for that, that's a basic counting principle. You're just going to multiply those all together. I hope this guy helped you. So tomorrow is just this video, and you're going to be studying. Ask me any questions. I'll try and help you all day long. And the quiz will be on Thursday, open from 8 a.m. to 10 a.m. unless you make arrangements with me for something else. So it must be completed by 10 a.m.